Okay, so in each of these situations, we're going to represent the object with a particle and then sketch all the forces acting upon the object and making the length of each vector represent the magnitude of the force. All right, so I'm doing basically a free body diagram. So I'm going to draw a dot to represent my block. And I'm going to have, if I think about my um, just my object, so just this block, I'm going to have the force of the normal up, and I'm going to have gravity down. So I'm going to translate that over here. So this is the force of the normal, and I'm going to have the force of gravity here. And there's no forces in the x direction, so my net force is 0 and no acceleration. This is an object slides at constant speed without friction. So if I think about uh, my motion map, I should have something that looks like this, where all of my velocity vectors are equal, right? And so if I were to draw the free body diagram first, I'm going to draw my boundary. And so again, I have the force of the normal up, I have gravity down, force of the normal. Since it's at a constant speed without friction, that means I have no forces in the x direction. So again, I'm going to draw this over here, force of the normal. This is force of gravity. These are equal and nothing in x, so my net force here is also equal to 0. This example, the object slows due to friction. So I'm going to have a motion map that looks like this. A little bigger. A little smaller there. A little smaller there. And that, something like that. And so drawing my free body diagram, I represent my block with the dot. I'm going to draw my boundaries. This is my force of the normal. This is my force of gravity. And now it's slowing down. So in my motion map, my acceleration is in this direction. These are my V's. All right, so remember that my frictional force has to be in the same direction as the acceleration. So here it's going to be right at this boundary, right? That's going to be my force of friction. And when I translate these over, I'm going to have the force of the normal here. I have the force of gravity down. So the force of the normal and the force of gravity are equal. That makes sense because my object is not moving in the y direction, and my force of friction is this way. So I have an unbalanced forces here. All right, in this example, I'm going to draw my boundary just around my block. So I have a force here of tension. Oops. Force of tension, and now I have the force of gravity here down. And there's nothing in the x direction. So my free body diagram, I have the force of tension up. And then opposite and equal is the force of gravity down. So my net force is equal to 0. Erase. Okay, in this example, the object is pulled by a force parallel to the surface. So draw my boundary. Force of gravity is down. Force of the normal is up. And this is my F pull. Translate that over to my free body diagram, and I have the force of the normal up. Force of gravity down, equal and opposite, because it's not moving in the y direction. And then I have the force of the pull is to the right. So I have a net force and an acceleration to the right. In this one, I'll draw my boundary. I've got force of tension this way. I have a force of tension this way, and we'll call this one 2 and this one 1. And then I have the force of gravity down. So I'm going to have translate over that to a free body diagram, and I'll have the force of tension 1, this force of tension 2, and I'll have the force of gravity down. And so this isn't quite vertical, but you get the idea. So these are balanced forces because my block is not moving. So my forces in the x direction are balanced and my forces in the y direction are balanced. We could look at that further if we wanted to. If we had more information, we could calculate the x component of Ft1 and determine that the x component of Ft1 is equal to Ft2, and the y component of Ft1 is equal to Fg. Okay, this example, my object is pulled upward at a constant speed. So that's my object. I have the force of tension, and I have the force of gravity. So now I've got my free body diagram. I have the force of tension, which is up, and I have the force of gravity, which is down. And these vectors should be equal because the object is being pulled upward at a constant speed. So since it's not speeding up or slowing down, then my y vectors are equal and opposite. In this example, my object is falling and there's no air resistance. So this is my object. So the only force that I have is the force of gravity. Nothing is touching my object. So my force of gravity is down, and that's the only force acting on it. The ball is rising in a parabolic trajectory. So I've got my object, and the only thing acting on it is gravity. And I can translate that into a free body diagram, and all I have is F sub g. This is an example. The ball is at the top of a parabolic trajectory, so I've got my ball. This is F sub g. And translate that to a free body diagram, and all I have is F sub g. So these three examples are all the same. So each of these has an acceleration downward. So 8, 9, and 10 all have an acceleration downward.